So in this video, we're going to be talking about how to graph a rational function again. It's just a further example from part one, which had a fairly simple rational function. This one's going to be a little bit more complex. Now, if you want instruction again on how to do each one, go back and look at part one of graphing rational functions, and it has detailed instructions written out on how to do each part. Okay? So let's take a look here. State the domain. Remember, we set the denominator equal to 0 and solve for x. I apologize for that. All right, we set the denominator equal to 0 and solve for x. So that's what I'm going to do here. Okay, I'm going to say x squared minus 2x minus 15 equals 0. And I'm going to go ahead and factor this because, well, it's a function that needs to be factored. So I believe we would probably do good to have, say, this is x minus 5 times x plus 3 equals 0. So that means, or not equal to 0. Don't forget, not equal to 0 for your domains. So that means our domain is x not equal to negative 3 or 5. Okay, that's going to be our domain. Now later on this might also be asymptotes, but we'll take a look at that as we get there. All right, so moving on, we're going to now find the y-intercept. Now, if you remember from a previous video, y-intercepts occur where x is 0, or where the function is, where the x value of the function is 0, because that means you're on the y-axis. So to do that, we just set all x values to 0. So we say 2 times 0 squared minus 8. Over 0 squared minus 2 times 0 minus 15. And we get 8/15. And that's okay to have a fractional value. We'll just estimate where that follows on the graph. This is very close to 1/2, so you just go a half a box. But remember, we're writing a coordinate here. This is the x value of your coordinate. So we say 0, and then this is the y value of the coordinate, so 8/15. Okay, we want to make sure we have that as we move forward to understand. Now, the next thing we find, of course, is the x-intercepts. And the x-intercepts, remember, are found by setting the numerator equal to 0, because technically we're solving the equation f of x equals 0. Okay, but we really, because of the nature of the fraction, we only have to set the numerator equal to 0 and solve. So that's what I'm going to do. Now remember, this is plus or minus 2 is your answer here. So that means we have two coordinates. Okay? We have two coordinates, 2, 0 or negative 2, 0. So we'll have two x-intercepts for this particular graph. So be careful and remember that as we move forward. Now, horizontal asymptote. Again, in a future video, I'm going to change that to end behavior, and I'll show you what that means as we go forward. Okay, but in this case, to find a horizontal asymptote, you take the limit as x goes to infinity and then evaluate your function. Now remember, you just look at your highest powers. Notice you have the same weight on top and bottom, so it's the ratio of those coefficients. So y equals 2 is going to be your horizontal asymptote. Then we move on to vertical asymptotes. And these are all the parts you need to put together the graph. You have to have all these parts in place in order to graph it. That's why I'm methodically going through each one. So again, to find your vertical asymptotes, we set our denominator equal to 0 and solve. Well, we already did that when we found our domain. So we're going to say that x equals negative 3 and x equals 5. Are our two vertical asymptotes. All right, I'm actually going to separate them to remind ourselves, okay, that we have two of them, and we're going to be graphing both as vertical lines. Remember, they're vertical dashed lines. So, and if you're unsure, remember this guy factored to x minus 5, x plus 3, and that's where I got those numbers from. Okay. So the next one would be intermediate behavior. Okay, remember, for intermediate behavior, we're finding the limit on the left and right of each asymptote. So I'm going to organize myself a little bit here. Since I have two asymptotes, I have two sets of intermediate behavior. So negative 3 plus of our function, and I'm just, instead of writing the whole thing out, I'm just going to use function notation for it. And to the left of the function. Okay, and then we do the same thing here with our 5. Okay, so from the right of 5 and to the left of 5. Okay. So, again, if you do the test with this, all right, if we plug, negative 2.9 into our function on top and bottom, we would get a negative number. Okay. So that means we're going to be going down on the right of negative 3. And if we plug in negative 3.1 into the function, we would get a positive number. So we'd be going up. Remember, we're looking for the sign of the number, not the number itself when we plug in. Okay. Now we do 5.1 and plugged in. If I plug in 5.1, I'm going to get a positive value. So that means I'm going up on the right. And then if I plug in 4.9, I will get a negative value. So that means we're going to be going down on the left. Okay? We're almost done. We have one more step before graphing, and this is an important step. Now remember, the rule here is to set this equal to your horizontal asymptote, which is 2. To determine where the graph crosses the horizontal asymptote, you set it equal to the horizontal asymptote. In this case, it's 2. And in fact, I'm going to make this 2 over 1 because I'm going to cross multiply to solve this. So 2x squared minus 8 equals 2x squared minus 4x minus 30. Notice what I did here is, as I cross multiplied, I distributed the 2 through the trinomial. Now notice a couple things here. The 2x squareds will subtract out. And then I'm going to add 30 to both sides. Okay? I'm going to add 30 to both sides. And when I do that, I get 22 equals 4x. Or x equals, or negative 4x, apologize, negative 5.5. Okay? Now remember, this is a coordinate. This is the x value of the coordinate, and this is the y value of the coordinate. All right? So we say negative 5.5, comma, 2 is an important part of our graph. All right? So let's take a look. Now we are going to graph it. Let me make this a hair smaller. Okay, so it fits on the screen. So let's take a look now. I'm going to do this one in blue to start it anyway. So I'm going to go through and plot everything. You remember my y-intercept, okay, was, what was it, 0, 8/15. My x-intercept, there were 2 of them, negative 2, 0, and 2, 0. My horizontal asymptote was y equals 2. My vertical asymptotes were negative 3, or x equals negative 3, and 5. Okay, and we had the coordinate where it crossed the horizontal asymptote as well. Okay, don't forget that one, at negative 5.5, comma 2. So now we go through and plot all this wonderful information. So 0, 8/15 is about 0, 1/2. So it's a point right about here. Then we have our intercepts, x-intercepts, 2, 0, negative 2, 0. Now we have our horizontal asymptote, which I'm going to graph. Y equals 2. Okay. And label. Remember, we don't have to label coordinates, but we do have to label asymptotes. And then we have our vertical asymptotes at 1 at 5. Remember, these are dashed lines. I know these are not perfect lines, but you'll have to forgive me for that. And then negative 3. Okay, we plot those lines. Like so. Now we go back and deal with our intermediate behavior. Okay? Now remember, on the right side of 5, we were going to positive infinity, so we put an up arrow there. And on the left side of 5, we were going to negative infinity, so we put a down arrow at the bottom of the 5. And then on the right side of our negative 3, well, these I forgot to label. Silly me. I put a down arrow here because I'm going down. And on the left side, I was going up, so I put an up arrow. And now I can plot. Notice in this portion, and you have 3 zones. You have the left, the middle, and the right. In this zone, we just go like that because there's no coordinates to go to. We start at that up arrow and just kind of curve out towards our horizontal asymptote. In the middle, we start at 1 down arrow, go through the 3 points as best we can, and then go down to that arrow. And then finally we have this arrow here. Again, no points to go through, so we curve down towards the asymptote. And that's your answer. Now remember, these are functions, so your graph should pass the vertical line test when you're done. All right. Now this is part 2. Tomorrow we're going to do part 3, where I add in some more complexity. All right, thank you.